So hello, I'm Rishikesh from BS Physics third year, and this is our CWS project presentation, which comes under the course Fundamentals of AI. The title of our project is AI-based mental fatigue detection using eye movement and blink pattern analysis. What we are doing here is we use the standard webcam to capture a video and send back to the server, and it gives us the response if the person is fatigued or alert. So why it matters actually? It is often difficult for individuals to self-assess their fatigue level accurately. So sometimes we are too much concentrated in our work. Sometimes like we are driving or doing some task and we get fatigued. But we are too much into that we do not correctly self-assess that we are fatigued, which leads to increase in our reaction time. Then it affects our decision making and concentration. So solution to it is there should be some tool which will tell you that you are fatigued. So you will take a rest, take a power nap, come again and start your work, which will stop the errors and accidents. So building a practical AI solution for fatigue detection was our main goal. We developed a real-time system using a standard webcam to detect mental fatigue by analyzing eye blink patterns and movements. So what was our philosophy behind this project was we focused on learning and application. We prioritized understanding and implementing a complete AI pipeline from data to deployment. What was our another priority was to improve and don't reinvent. Utilize a build upon well-established computer vision and machine learning techniques like media pipe, which will give us the landmarks on a face, and the scikit-learn, which will help us to train our model. And that's how we built it a deployable product. It's a prototype. We made a backend, trained model, and a front end. So the working is starts with real-time webcam monitoring. It uses the user's webcam feed as input. Starts with facial landmark detection. How facial landmarks are detected? We pass the each frame to the media pipe, and media pipe gives us around 478 of the facial landmarks. With the help of those landmarks, we calculate the features like iris, aspect ratio, blink rate, average blink duration, and perk loss. We pass those features to the backend. Backend uses our trained model, which is also trained using our these features, and give us the response if the person is alert or fatigued. We send that response to the front end and show it to the user. That's how the total working is. So let's start with our demo. So before starting the demo, we have to go to our project directory, which is under the fatigue detection directory and backend. First, we'll start our front end. It's asking for the camera permission. Okay. And now, as you can see, it can detect my face. It's showing the face mesh around my face and is trying to analyze. It's showing connection error as it collected the data and tried to send it to the server, but it got the connection error as our backend is not started. So first we will start our backend. Look, so our server is started and it already started getting the post request at the predict endpoint. And now it's showing alert as I slept before start making this video, but as I start to blink more or try to increase the perk loss percentage, it will show that I am fatigued. If I widely open my eyes and show that I'm alert, it will show again alert state. So now I'm alert. So that's how it works. Next, let's move on to the, not the end, let's move on to implementation. So how we implemented it. The first starts with the step one, finding the eyes. So when we first get the footage, the first task is to locate our eyes. So how we did that is with the media pipe. This is here we have initialized the media pipe face mesh. We have given the parameters of face mesh like maximum number of faces, at how many faces from the image it will detect. Then we have given the refined landmarks as true, that it will fit the refined landmarks with the minimum detection confidence of 0.5. And the media pipe will give you 478 landmarks, out of which only 6 landmarks are useful to you, which are around your eyes. So step 2, quantifying blinks with EAR. Now we have to detect if the person blinked or not, because we are finding if person is fatigued or alert based on the blinking pattern. So first we have to detect the blink, and for that we use EAR. EAR is eye aspect ratio. What is EAR? EAR is eye height divided by eye width. So first we find the eye height. How we find the eye height? Let's assume I'll draw a diagram of a human eye. Okay, let's consider this is a human eye, and this is the P2 landmark on our eye, and this is P6 landmark. So what are the landmarks? Landmarks are nothing but just the coordinates on your face. Okay, so after finding these landmarks, we find the Euclidean distance between these 2 points. So we get the height of the eye. And the P3 and P5 is the height representing the height of the other eye. And we find the average of this both of the heights and divide it by the width of the eye. How we find the width of the eye? This is the P1 and this is P4 landmark. We find the Euclidean distance between the P1 and P4, put it here, and we get the EAR. And that's how this is the code to calculate EAR. Then we come to the extracting temporal features. So how we extract temporal features? The first temporal feature is blink rate. We have to find the blink rate. How we find it? We take the 3 frames at a time and find if the EAR was below the threshold. If the EAR was below threshold, then the blink was happening, and that's why we increment the blinks. For this, we use a window sliding method. We take the 10 seconds of the window and start to slide it with 5 seconds, and that's how the every time the 5 seconds overlaps and give us the better feature extraction. So that's how we calculate the blink rate, average blink duration, per loss, ER variance. These are all the formulas. After that, after getting all the features extracted, we save it into the CSV file and we start training our model. So we have used the random forest method to train our model. It is a actually classifier, right? So we are training the classifier using the random forest method. So first we have initialized the model random forest classifier. Then we have given it the n estimators, 100 estimators, random state 42. And then we tried to feed the model with the training data. Okay. And then we dumped a model, fatigue model, job. So before moving to the next slide, I would like to explain what is the random forest and what are the decision trees actually, because that will explain you more this slide. To explain that, actually I have took this sample dataset. Let's consider this dataset. What dataset is? It is a dataset of the chosen transportation method based on the gender, car ownership, travel cost, and income level. So if someone gives you the some gender, car ownership, travel cost, income level, you have to predict what transportation method he will use. Right? So how it is decided? It is decided with the decision tree. To build any decision, like if the gender is given, right, and car ownership is this, and the travel cost is this, then he should select this transportation method. Okay, so that's how we decide anything, right? Decide that we have to form a decision tree, and how that decision tree is formed, that's we are saying. To form the decision tree, commonly used method is ID3 method, which is common algorithm we use to form a decision tree. So how we do that is, to form any decision tree, we will need a root node. Okay. So first we have to deduce what will be the root node: gender, car ownership, travel cost, or income level. To do that, what we do is we find the information gain of the attributes. Whichever attribute has the maximum information gain, we choose it as root node. So how we find information gain is with this formula. This is the formula to find information gain. What we do, we find the total entropy of the dataset and subtract the weighted average entropy of the that attribute. Okay. So how we will find the total entropy? You will just see the number of rows with the transportation method bus, or number of rows with the transportation method train or the car, right? And you will find the probability of each subclass. Put that probability here and this formula, sum it all, and find the entropy of the data set. Same thing we will do with the for attributes. We will find the entropy, weighted average entropy for the each sub attribute here. Put it there in the information gain formula and find information gain. Whoever has the higher information gain, we will select it as a node. For selecting the next node, what we will do, we will form a new table. And new table will be, for example, you have selected gender as a root node. Okay. Now there can be two genders, female or male, right? Now we have to choose the next node, which will be car ownership or travel cost or income level, whichever will be. So how you will choose that? First, you will take a table with only entries female as a gender. You will form the new table here, and now you will again find the entropy of the whole table, the whole data set, and subtract the weighted average entropy of the each remaining attribute from the total entropy, and find the information gain of the all remaining attributes. Okay, and then you will see the which attribute has the highest information gain and put it as the next node. So that's how it will work. I don't know if I was able to explain it, but that's how it works. It's not actually needed for a project that much. Okay, so let's move to the next slide. Okay, we understood the random Poisson decision tree with common algorithm, which is ID3. We're done with this. Now we move to the connecting everything. So how we connected everything, right? So first we have to build the API, because we need some interface to connect with our model, right? That's why we made this API using the Flask Python micro framework, which loads our fatigue model job limon when we start the server, provides a predict endpoint where we send the request, and returns a prediction to the front end with alert or fatigue response. And we have designed all the front end using single HTML file using vanilla JavaScript. It is a prototype, that's why we don't use any fancy work like frameworks or something. After training the model, we got these results and evaluations. We got the classification report as this. The precision was 0.79%. We used a dataset, UTA RLDT dataset, and achieved almost 80% of the accuracy, which is good. As if the accuracy is more than 90%, we consider it as the overfit model. So these are all the results and evaluations of a model. Okay, and that's the end. That was our project.